We recently signed a large contract with CPS Energy to create about 250 megawatts of clean capacity for them. So we are in the midst of moving everybody from Raleigh, North Carolina to San Antonio. We used to have an office over on 13th Street and here, and we very much enjoyed our time here. A little bit about us. We've got four small investors in us, but they're strategic investors. Verizon's providing some of our communications backhaul. GE's helping us with some of our manufacturing. Qualcomm's helping us with some of our modems, and Constellation actually hosts our data center. These are some of our customers that we currently got right now. I guess the important part is in this industry we see people wanting to pilot a lot of things. These were our first three customers, and they've actually all gone to commercial terms with us. As you see, Bluebonnet Perdalis are two here local as well, and we've got some installations going there along with LCRA. Ty Monnier from LCRA is here. You can ask her lots of questions about things. And then we have one up in North Texas at Grayson Collin. If you leave here with nothing else today, one of the things you want to know is that what we really do at the very essence of what we do is we go into small businesses and residential areas, and we aggregate the capacity that's existing in that home and present it back to the utility as a clean source of capacity and energy that is dispatchable in real time. So what we're doing is creating two-way, real-time control of energy use between the consumer and the utility company. So at a high level, I'll walk you through a little bit about what we do. Consumer goes into a web portal and basically answers a series of 13 questions. Those questions help set up profiles of how the devices should be used for a weekday, weekend, vacation, and a work-at-home mode. Inside the home, we create a home area network for the consumer that they access via that web portal, and we basically attach to the high energy using devices, swimming pool pump, HVAC, and a water heater. We attach these device controllers. I'll show you one in a little bit more detail, and those basically give us control and measurement. We also replace the thermostat with a programmable communicating thermostat, and that thermostat actually controls the HVAC. We duty cycle on or off the AC. We don't really touch the compressor. Everything inside that home works on something called Zigbee, which is a 900 megahertz unlicensed frequency band that the utility industry has coalesced around. We're guys from the wireless industry. We don't know exactly how the utility got into Zigbee or why they're using it. We are using it. We're probably going to bring out private Wi-Fi as well to use inside the home. Outside the home, we basically then install a meter. And in that meter, we put a gateway, and that gateway has the CPU, the RAM, the battery backup, the Zigbee chip, as well as a Verizon modem, because we basically backhaul all the data off all those devices and all the meter information back through the Verizon Wireless 3rd and 4th generation networks. We take it then through a secure IP backhaul back to a NERC CIP certified data center that resides in Baltimore, Maryland. And we package all that information up into something called a flat file, or we won't get too technical, for however the utility wants to take that information in their existing billing systems, their customer information systems, or their meter data management systems. So that's kind of the 10,000 foot view. I'll take you in a little bit closer. This is our device controller. It's a patented device that we basically expect the utility to use 24/7, several times a day. That gives us as much information as fast as we want, when we want it, or when the utility actually wants that information. And that has to be installed on all those high energy use devices. We know that once we install on those three devices, we get somewhere between 40 and 60% of the total energy usage in that home during peak times. This is just an off-the-shelf radio thermostat, Corporation of America thermostat. This one happens to be a CT30, they call it. And it's got you can see kind of in the background there, it's got a little Zigbee module that goes back in the back of there. And that's what communicates with the HVAC and the gateway to allow commands to that unit. And then there's a little bit better shot of our gateway that goes in underneath the meter glass. So what's the value proposition here? The real value proposition for utilities is they create a clean energy and capacity reserve. If you've got one of the 14 or 16 states that you've got renewables legislation, we actually can help you meet those mandates. In fact, if I know that when we run something that's called a conservation event and we do some load shedding, if I know what the fuel mix is for that particular time period, I can create the world's most accurate carbon measurement down to the device, actually down to the watt. Who owns that carbon credit in the future? Who knows, right? It'll be the next great tax. From a transmission and distribution standpoint, we can actually help utility companies reduce their transmission fees if they purchase energy from somebody else and don't do their own generation. Because we're at several different points along a line, we actually can give real-time voltage information so that utility companies can actually do some conservation voltage reduction. And then, finally, from a EV standpoint, the charging station just looks like another appliance to the homeowner, and basically the utility company could send pricing signals. We've all heard about time of use dynamic pricing. They can receive some signals or send signals to the user. User can also set that just as when they want it to be charged, and can also know what the cost is. What's the value proposition for the consumer? We know that in our pilots thus far, in our commercial installations, we're seeing right around 15 to 20% energy efficiency amongst the participants. People say, Jeff, that can't be right. And I said, well, when we go into the homes, and we've kind of looked at this from a national standpoint too, we know that only about 15% of the homes actually have programmable thermostats. But when we actually went into the homes, we saw about the same number that had programmable thermostats, but only about half those people actually had programmed their programmable thermostat. So right off the bat, we saw huge energy efficiencies because people, even if they had a programmable thermostat, didn't actually have them programmed. Other part of it is very few of us ever put a timer or any sort of control device on our water heaters, so they just duty cycle all day. So what we're able to do is basically eliminate a lot of that ghost consumption during the day by basically shutting that water heater off when nobody is at home. The consumer, if CPS Energy or any of our Blue Bonnet or Pernalis basically runs a conservation event where they're basically shedding load under the permission of the consumer basically can opt out at any time. That's very different than traditional demand response programs. Consumer walks over to their thermostat, hits a button, and basically says, I don't care to be part of this event today. Or they can go to their web portal and they'll see that their opt-out light is lit, and they can go click on that, and then they're not in that event. So for the first time, you've got a load shedding process where the consumer actually has control. Now, in reality, when we run these control events, and Ty can tell you, we get very, very low numbers of people opting out. Well, why is that? Because at the very start, they've told you how they want their energy to be managed. They've basically told you, giving you some permissions to do some of those things. And unless they've had a change in lifestyle, they've had a baby or a student at home, or they're starting to work at home, they're not likely to opt out of the event. We see less than about a 3% opt-out rate anytime we do a conservation event to shed load. Consumer gets a free home energy management system, and they get anywhere, anytime access. This is kind of an example of the initial questionnaire that people get. We initially, when we go in and install this, you get the Energy Star profile. If you've ever tried to live under the Energy Star profile or seen it, I don't think anybody could survive in their home during the summer in Austin, Texas under the Energy Star program. So they're pretty motivated to get down here. They answer 13 questions. What time do you get up in the morning? What time do you get home at night? What time's the first person go to bed, or last person go to bed? What time's the first person get up in the morning? What's your optimal comfort level in your home in the summer when you're home, when you're not home? Those kind of questions. That basically sets up, like I said, a weekday program, a weekend program, a vacation program, and a work-at-home program. And then from there, they can go in and tweak it further. This is just a little example of one of the initial page that they get, and they can see some of their information. Right now, you can access this off of any BlackBerry OS 6, any iPhone, iPad, tablet. And so consumers got mobile access to their portal and can make changes as they need to from any place, anywhere. This just shows somebody's settings for a workday. Graphically tells them, what days they've got set for workday programs. They can make easy changes to their temperature settings and basically make any changes they want to make very easily, whether it be on a mobile device or via a laptop or any other internet connection. People can better understand their savings. We can basically show them what their savings estimate is. We can show them their most efficient days, their highest use days, what were the hottest days, what were the coolest days. So lots of information. In reality, what we see is people go into the portal, they set it up. The second month, they go in there and check it and make a few tweaks. And pretty much after that, it's a set it and forget it type of situation. See, about maybe 10% of the users want to go in there and tweak and play around with it every month. Just another example of not a lot of people know what a kilowatt hour is, so we try to give them some sort of reference point. How many miles is that equivalent to? Pots of coffee, how many times you run your dishwasher? From a utility standpoint, and why CPS is interested in this, is because we are going to install somewhere between 140 and 150,000 homes and small businesses in San Antonio. That's going to roughly give them about 250 megawatts of capacity that they can use. And this is how we kind of show this to them. They said, here's how much is available right now. So what this is saying is, hey, this is what's duty cycling in these 150,000 homes. Here's how it's broken up by device. Here's how many what proportions of water heater, what proportions HVAC, and something else. We can divide. They can take that information and divide it up by geographic areas, by feeder line, by distribution line. They could take the most energy efficient homes. They could take only the HVACs. So they have an ability to shed load by any sort of grouping they want to do it in. We give them a little bit of information by device and then compare it to outside air temperature. And so this is kind of just gives you some examples of some of the information that we give to the utility companies that are using it. This basically tells them how much load they have available to shed in a different graphic format. So this kind of shows you a little bit about if they want to do some sort of load shedding event, how those groupings can be done. They can be done by targeted devices as well. So maybe you want to do the less invasive things. You only want to hit the pool pumps and the water heaters. And then lastly, we basically have a great BI tool, business intelligence tool. So however you want to take that data, you can slice and dice it and figure out, what's really going on out there at the end of your line. So with that, how did I do? I stay under 10 minutes even though I'm a...
Good job, yeah, thank you.
Thank you.
We've got time to take questions from the entire group. For Brewster, Barry, or Jeff, do you have any questions? Surely, we must have. Must be a question out there somewhere. I'll try one off. Probably my last. As you say, the customers, actually use
It's a basic notion of everyone we're working with right now that the utility is going to provide this. And why do they provide that? Well, they get a very, very detailed financial performance. All that capacity has value, right? And so right now, ERCOT is very interested in taking a lot of this capacity and using it to address next summer's heat. If we have another summer like this, they see this as a great source of dispatchable load for them. And so there's great value in that. So right now, not to bore you, but it's we can play this into the emergency interruptible load service market in ERCOT right now. So it's a lot of what LCRA is looking at is the EILS market viable? Is the negative energy market viable? Is the taking a look at transmission costs, all kinds of things. So there's a lot of value there.
We take a slightly different point of view on that. We think that this revolution will be led by the consumer, and that the pain points are being felt by the ratepayers, and providing value to those ratepayers is of primary importance. We certainly bring the value back to those ratepayers by connecting to utilities and providing those kinds of programs from the utilities as they're able to implement demand response programs. But there's a value proposition for the end user and providing that value to them.
Yeah, I agree, Barry. I think it has to be something that's voluntarily offered to the consumer. That's a good discipline for businesses to have, because if customers don't want it, they won't buy it. And so the key on their right is to make it something customers want to succeed.
And what we're finding out there is there are a lot of people that are very interested in saving, having an energy efficiency. But what we really see is people voluntarily sign up because the green they're really worried about is the green in their pocket. And when they start seeing 15 to 20% reductions in their energy usage, they're very vocal about it to their neighbors. And so we get quite a bit of sign up very quickly.
Any other questions?
A lot of the discussion so far, Barry, between your stuff and with Jeff, what you were talking about, has to do with extending the control of the energy outside of the home. And so you add a whole bunch more of a trust level in between there. You know, I lock up my home and I have access to a thermostat. I can control right there what's happening. If I'm here and I'm controlling it through my smartphone, there's a whole lot of people between me and my house that can get in there and interrupt my control. So what are you folks doing to protect my information and protect that control so it's just me?
So on a security standpoint, we believe that we're using the same security levels that any financial institution would use, using third and fourth generation wireless technologies. Inside the home, everything has got their own certificates. There's a high level of security even inside the home. So we've been asked that question numerous times. Part of the reason why the data center is sitting in Baltimore, Maryland is because it's inside a NERC facility. So we got those questions a lot early on, but I think as we've brought Verizon in and people have gotten more comfortable with using third and fourth generation technologies, that issue hasn't become as big of an issue. Some participants may not want to do it because of that, but we're not running into that, in general.
I'll just take a crack at that too. This smart grid has often been referred to as the energy internet, and what we found is that we had all of the hard lessons that were learned during the internet implementation around security, and we have to build security in from the ground up, following standards, NIST and other standards for security. The security on this data is extremely important.
Yes.
I just want to make sure that I'm understanding you mentioned control, but the way I understand it is what you're offering leaves full control of use with the consumer. What you're offering gives the consumer information to make good choices, but also gives the utility some control.
The consumer goes in, answers 13 questions, and then sets the profile of how they want their energy to be used. They also grant permission to the utility to cycle off their devices during peak times, but they can go in and opt out of those events at any point in time. But when you set up those profiles, you basically say, if my optimal temperature is 75 during the day, because really nobody's home, but I'll give you another 4 degrees to allow my home to drift to 79, then those are the 4 degrees that Austin Energy could take to cycle off your air conditioner for another 4 degrees in order to shut that load. But ultimately, the consumer, because this is in real time communications, has ultimate control.
And whatever the systems are, the utilities are going to try to play in this area because it has real value to us. It keeps us from having to buy that $60,000 or $6,000 a megawatt power in August when the normal price is $30 a megawatt. And we don't want to go there. So having these kinds of resources that we can take offline have real value to us, and we can pass that value on.
Yeah.
Austin Energy can pass that value on to the customers. Regardless of what type of system it is, utilities are going to try to play in that arena.
We're getting a lot of calls right now, actually, because people are bringing on a lot of wind generation, and they don't see the sense of firing up gas-fired turbines as a way to address intermittency of the wind. They want a clean energy source to address that intermittency. Because this is real time and can react in seconds rather than hours, this can be a source of regulating reserve for wind or solar.
You mentioned the example you just gave of letting the temperature float from 74 to 79. I'm wondering if the technology includes temperature data from inside the home, so you know what the temperature in the home is.
We're actually taking that information off the PCT that feeds it through our gateway on the meter and then back to our data center. And then we also have outside air temperature information that's also
the
fed in.
PCT is
The brown ball thermostat.
All right, so it's integrated to that level.
That's right. So that Zigbee chip inside the thermostat actually communicates back to the meter.
Barry? We believe full control of the energy in your building belongs to the person paying for that energy. Someone very smart once told me the quickest way to kill smart grid is to shut people's air conditioner off in the middle of the hot summer. We also believe that the utilities will provide incentives for people to utilize demand response programs, and that by doing that intelligently, reducing compressor cycles but not affecting comfort levels is the way to achieve that goal.
Yeah, you know what the challenge is, so cycling the air conditioners, you and your electricity is 12 cents, 12 watt hour, say you 3 to 4 cents. They turn off your air conditioner. What'd you pay for that? Not saving that much, right? So, when you say 3 to 4 cents an hour, to have somebody else come turn off your air conditioner in the middle of August afternoon, that's why we think there has to be some other value proposition. If these systems can do many things for you as consumers, then it becomes your home security system, and it helps you charge your car, it helps you, take care of your loved ones and things like that. An app store for the home. Then there are other things other than saving literally pennies in a given hour. So, when we work with Synergy, because that gives us detailed understanding of what's going on with almost every major energy device in the home, so we can find out what are the problems people are trying to solve. Because they're trying to do, when you turn your AC down, you're trying to solve the problem to keep yourself cool, comfortable. So are there other technology approaches that help you get cool and comfortable, like zonal air conditioning, where you can cool just individual rooms? So they're all, if you're using water a certain way, when you're trying to achieve some things with water, like getting clean, keeping your lawn alive, things like that. So what are the things people are trying to get done, and are there other ways that companies could offer a product or service to help people get that job done? So I think that's probably an important value proposition.
Here's one about homes. So we have a program to build and rate green homes.
Mm-hmm.
The data that's being collected, is it being collected in such a way that we can get performance information out of that as compared to the normal stock homes out there? So that information could be used for future appraisals. Is that?
You had it perfect until we got to that, so that information can be used for future.
Well, as an example, I
Yeah.
mean, that's a problem that needs to be solved.
It is.
Can this information be used in a way like that?
If you were using a home, and I'll jump in, you guys can go ahead and correct me if I get this wrong. If you had your own home energy management system, your own system, you would have that data. If you're relying on us to give it to you, there are a lot of privacy concerns that we would have to get over, a lot of privacy hurdles imposed on us by the PUC that we would have to get over to give you, where we give the homeowner that data if they agreed to it. And so it would be more complicated for us to give it to you than for you to take it off your own home energy management system. We have the data, but sharing it is difficult for us. If you have the data, you can do whatever you want to with it, if you can get the appraisers to recognize it. Did that help?
A little bit, but not much.
Herman?
How do you combat the homeowners that are not all that necessarily interested in green, but they're more interested in Big Brother watching? And they don't want smart meters, they don't want smart grid. Because to them, Big Brother's watching and Big Brother's going to take over their life.
I think
How do you combat that?
there's two things involved here. Every one of our utility customers makes it a voluntary program. And what we find is people get very green in this regard. And when they start seeing their neighbors saving 20% on their electric bills, somehow the idea of Big Brother goes away to a certain extent. And so, but the bottom line is it's a voluntary program everywhere we've gone. And so if you don't want to be involved with it, you don't have to.
So if I go out there and sell your product, they're happy.
You sell our product.
In other words, to make them happy, I got to sell your product.
I think what makes people happy to participate in our programs, and we've gotten, if I can tell you, is we've gotten probably the highest customer approval rankings of anything that some of their consultants have ever seen in these kind of programs, is because they're getting a home energy management system. It's easy to use, but the bottom line is they're saving 15 or 20% on their energy use every month.
But their privacy fees out there.
But all the profit.
That's a long debate we could have.
That's a long debate.
You see why, this is a good example of why it's so much more challenging in the residential market. In a business market where the electric bills are, it's a big cost item. You run a factory or an office. If you have a single user in an office building, it's a big deal. But in Austin, I think it's about $950 a year is the typical electric bill for a year. So let's say that translates out to about, let's say $80 a month. So saving 10% a month is saving $8 a month. For some people that matters. But for a lot of people, it's like, well, first of all, what would you pay to save $8 a month? Well, that's a challenge. That's why we think it has to do more than manage energy. And also, even if it saves you $8 a month, but you got someone who can turn your stuff off, help them out, help them make more money. That's the logic, right? There's a reason, there's a very common sense reason why distribution utilities and retail utilities want to level that load. And Richard got to it, right? In this past summer, for utilities, they were selling electricity for $60 a megawatt hour on the retail side, and it was costing them $3,000 a megawatt hour. The average marginal price for electricity on the balancing markets at 4 p.m. was $850, and the break-even price was $60. So the utilities, there is a very common sense reason why they want to level loads. But customers, they're getting it for $60 divided by 1,000, for 6 cents plus. So they're getting basically 11, 12 cents an hour. So to save, $8, really, it may not be the compelling value proposition. So you're getting into something about why the return has to be something more, we think, than the energy.
I think we've got time for one more question, Roger.
Does that mean also, the energy company's going to pay me $750 a watt for clocking afternoon if I put in solar panels?
Not exactly, but it does mean that solar power, because of the way it's generated and the time it's generated, may have more value than the fossil energy that we're typically generating. And we're looking at several options to make it possible for the customers to realize that value.
And by the way, you're getting into something though, which is what's it worth to a utility not to use megawatt hour, megawatt at 4 in the afternoon on a summer afternoon. It's worth $750 on average, right? And so that means that's the business case of things like solar and things. Because interestingly, it turns out that the way that the markets work is that a utility is more profitable from selling less electricity on summer afternoons. So that's why energy efficiency is in the business interest of the utility, and that's why solar rebates are in the business interest of the utility. Now, the trick is the pricing, right? And it's not an open-ended deal. You got to figure out what is that cost benefit and price it accordingly. But this idea that selling more electricity is always more profitable is just flat out incorrect, it turns out. So that's the reason why this all has a business case.
We believe in a future where you, the consumer, have visibility into your consumption. That's your data. We also believe that you, the consumer, will be presented signals from the utility of what that reduction is worth to them, what it should be worth to you, and you get to make those decisions about when that meets your own value and when you want that consumption to be reduced because you've received enough incentive